One of the first computers I emulated was the Sinclair Spectrum. I wasn't going to emulate the American version, which is the Timex Sinclair 2068, because I thought that it was an exact replica of the ZX Spectrum, but I actually found out recently that it has an AY sound chip, and it has several different screen modes. So it's got 4 screen modes, whereas the Sinclair Spectrum just had 1. And in this video I'm going to just go over the screen modes that the Timex Sinclair can emulate, because I've done a video on the actual ZX Spectrum emulation last year, I think it probably was. And I'll go over the source code at the end of the video as well. So this is the boot up screen. You can see the copyright message is Sinclair Research and Timex Computer Corp, and it operates exactly like a ZX Spectrum in all other ways. But in order to actually demonstrate the display modes, I also actually have to run it with a cartridge, which is the OS64. So there's a cartridge which allows the actual screen modes to be used from BASIC. So the Zebra Systems OS64 cartridge will come up with this boot screen when it's inserted, and it comes up in the 64 character mode, so it's got 64 characters across the screen as opposed to the 32. It still has 24 characters down the screen, but from here I can actually run some basic programs. And first of all, I'll demonstrate the mode 0 and mode 1. So the 4 modes that you can actually have on the Timex Sinclair Spectrum, mode 0, which if I run this basic program, will actually display exactly the same as the mode 0 or the mode on the original ZX Spectrum. And but what I have to do is actually move the character set in BASIC first of all out of the way of the second display area, because there's 2 display areas. So this is the first display area, which is the same as the ZX Spectrum display area, but in upper memory further up the display area, you can actually have a second display. So what I'm doing on the first display here, I've printed some text and I'm plotting the sine wave. And then what I'll do is I'll switch to display mode 1, which is in a different area of memory, and that first display mode, that still retains exactly what it has. And so in this second display area, so I've printed some text, I'm going to display a cosine wave, and then after the cosine wave has actually been displayed, I'm going to switch back to display 1, and you'll see it immediately switch back and display what is on display 1, and then I'll switch back to display 0 again, and I'll switch between them, and you see that you can actually switch between the 2 display areas. So that's a big advantage over the ZX Spectrum, the original one, because you've got these 2 display areas, and in BASIC you can actually make use of this and actually do some rapid display updates. And so after this is finished running, what I'll do is I'll actually demonstrate display mode 2, so that's 0 and 1. This is display mode 6, which is the 63 character one. So if I just reset, and I'll load up the text file which actually shows display mode 2. Now display mode 2 is the same resolution as display modes 0 and 1, but it's a high color mode. So if I run this, so you see that when I'm setting clearing the attributes out, first of all at the top of the display, the actual attributes are much smaller. So on a original Spectrum and in display mode 0 and 1 on the Timex Sinclair, each attribute is 8 by 8 pixels. So it's basically a character size. So each character on the display, you can have a ink color and a paper color, and you can make flash or bright. But in this high color mode on the Timex Sinclair, each attribute is actually 8 pixels by 1 pixel. So for every character you can have 8 lines of different attributes on the display, and so you can actually have a much higher resolution of color on the display, whereas the pixel resolution is exactly the same as the original Spectrum. So before I go through the actual source code of how the display is actually handled on the Timex Sinclair, I'll just do one more source code example, basic example. If I'll do a Mandelbrot plot on the enhanced color mode, And what I'll do is I'll speed up this because it takes about half an hour to run in real time. But this is in the high color mode. So that rendered the Mandelbrot fractal at a resolution of 64 by 192 and 16 colors. So I'll go over the source code of the emulator and the differences between the Sinclair Spectrum and the Timex Sinclair. So in here, there's a port which the Timex Sinclair has to set the display mode, and it's port FF, or 255 in decimal, and it selects whether you want a screen mode 0, 1, high color mode, or high res mode. And it also has an ink mask for high res mode, because in high res mode there's no attribute bytes for the actual display, so you only get one ink color you can select. You can select any of the ink colors which are on the actual spectrum itself, but the ink color is set here, and then the paper color is selected automatically as a complement of the ink color. So once you set the ink color, it will set the paper for you, or if you set the paper color, it will set the ink color for you. The border color you can still select separately, just like you can in the ZX Spectrum. And also there's a bit in this port which has an effect on the bank switching of the memory, so that is to be considered in the emulation as well. And then down here, the audio device, the AY sound chip, the ports are there as well, which is different to the Amstrad Sinclair ports for the AY sound chip, so it's not compatible with the actual software which runs on the Amstrad Sinclair as far as sound is concerned. So the actual source code itself, I'll just pick out the Timex Sinclair differences. So there's paging of memory like there is on the 1 to 8K spectrums, but it's not the same as the paging for the 1 to 8K spectrums. So on here, every 8K block can be paged between this and an alternate ROM 8K block, or an external cartridge 8K block. And the memory addresses which get paged are exactly the same for each block that you're paging, so that it doesn't move memory up and down in the memory area either. And then there's the AY sound chip callbacks being set here, so that the sound is enabled. So on a reset of the Z80, it resets the AY sound chip, and also remirrors the memory back to the standard area of memory, just in case it's been paged out at some point during the previous emulation. And it sets the display mode back to 256 pixels across, like the standard ZX Spectrum, so it makes sure it's in the right display mode when the CPU gets reset. So this is the display mode callback, and in the display mode callback you can select what the actual display is. So for high res display, it sets it to 512 pixels across the display, whereas all other modes are the standard Spectrum 256 pixels across the display. But also, like I said previously, there's a bit in this port which actually dictates some of the paging of the memory, so I have to repage the memory depending on what the actual bit was, which may or may not have changed during the output to this port. And then there's the memory page callback port, and depending on what's actually the differences on the outputs of these bits, it may want to change the paging of memory. I'm calling a function here because it has to page memory in two different areas. So I've got this common function down here, and this is where it decides on what was output to those two ports as to how the memory is being paged. And like I say, it can be paged between internal memory or an alternate ROM, I guess internally, or a cartridge externally. The actual keyboard callback is exactly the same for the Spectrum and the Timex Sinclair. And then this is the clock callback, and so it's pretty much the same. There's the AY sound chip it wants to do the playing of sound for, but in here it's all pretty much the same. and this is where the display gets updated. And so it chooses what mode it's doing. So for high res mode, it has a range of memory where the bitmap is, which it will just plot out. Like I say, there's no attribute bytes for the high res memory, so you don't have to consider that at all. You just have to make sure that the front and background colors are selected correctly. And then for all other memory modes is this area down here, and it decides whether it's on screen 1 or screen 0, and it selects the starting memory address for screen 1 or screen 0 mode. And the actual rendering of both of those modes are exactly the same, so it just has to care there about what the actual start address is. And then for the actual high color mode, it can actually render that in this area as well, because the difference is just how it gets the attribute for the actual displaying. So like I say, for attributes on the high color mode, it does 8 attributes per character, whereas the standard mode does 1 attribute per character, and that's the only difference. And but it provides such a decent extra graphic area for the actual Timex Sinclair. I actually prefer the actual Timex Sinclair to the standard Spectrum now, because the high color mode is really a neat feature, and also the 63 column mode is a neat feature. Although on the 63 column mode, you can't really run that on a standard CRT because the standard CRT resolution isn't really big enough to actually make that visible. So you need to run an RGB monitor for that particular mode.